All right, let's get into systems by graphing. By graphing is super easy, especially if they give you the graphs, which they did in 1, 2, and 3. You're just going to find that intersection point. So where do the graphs intersect? Easy peasy, right here at 3, 4. All right, now what if they don't give us the graphs? No worries, because guess what? We've been practicing graphing equations of lines. So keep in mind, it's y equals mx plus b. M is your slope. B is your y-intercept. And let's get started. So for the first line, we're going to graph the point, -4. Our slope is positive, so I know it's going this way. I rise up 1 over 2, and I can keep that going. I use my trusty straight edge, and this is an equal sign. So it's solid. We're not doing inequalities now. Ooh, that was bad. And then graph that line. So Jimmy, I know that was a terrible line, but make sure you are doing this as well. Okay, now let's look at the next one. Uh-oh, it's not y equals, so get y by itself. All we have to do is subtract 2x on both sides. We get y equals -2x plus 1. Graph your point. So it's +1 for my y-intercept, and my slope is negative, so it's going to go down this way. So it's down 2 over 1, and then connect the dots. And then find where it intersects the correct point. Yes, again, I know I messed up, but find where it intersects, and it intersects here at 2, -3. Really, the only time I would do graphing is A, if they give it to you, or B, they give you a graph, which they did in this case. Otherwise, I wouldn't do graphing because it's easy to mess up if you aren't given graph paper. So, Miss Beist, what do I do if they don't give me a graph? Well, guess what, Yasmin? I'm going to show you. So, sorry. Oh, no, I'm not going to show you yet. So, say I'm given, we're only going to talk about this top section. The bottom section is practice for you. What happens if the lines don't intersect? Well, if they have the same slope, which they have here, I know that these are parallel. And if they're parallel, they don't have a solution because parallel lines never touch. Is that crazy or what, Amarian? Crazy, I know. So if they are parallel, they don't touch, there's no solution. Okay? Here, I see them intersect. There's only one solution, like we saw on the front. But what about here if they share the same line? So they're parallel, they have the same slope, but they also have the same y-intercept. What happens? They have an infinite amount of solutions. So infinite many solutions. Okay, so Fabian just asked, what if I'm not given graphs? Well, guess what, Fabian? This is what you do. One way is by substitution. So that's exactly what you're going to do. You are going to take, we see how this says y equals, we're going to take this entire thing and we are going to literally substitute it in for y in this expression. That's what it means by substitution. The time to use this one is when you have a variable that's equal to it, that's equal to something else. So here, if I had a bunch of these, I wouldn't do this type. I would only do it if it says y equals or x equals. So we're going to take it and sub it in and solve for x. So we have 3x plus 2, 2x plus 5 is y, equals negative 4. So now we're going to distribute this 2. And we have 3x plus 4x plus 10, because the 2 times 2x is 4x, 2 times 5 is 10, equals negative 4. Combine like terms, 3x and 4x gives us 7x, and we're left with plus 10 equals negative 4. Draw your line and solve. Right now, 10, remember we're trying to get x by itself, so what's close to 10, or what's farthest from x, but is still on the same side, this 10. So we're going to subtract 10 on both sides. We're given 7x equals negative 14. Lastly, divide by 7 on both sides, and x equals negative 2. So is that it? Of course not, Aaliyah. That is not it. We've got to do more. We found x, now we got to find y. So again, we are using substitution. We're going to sub this negative 2 in for x in this expression. Y equals 2 times x we just said is negative 2, plus 5. 2 times negative 2 is negative 4, plus 5, and y equals 1. So our coordinate for this systems of equations is negative 2, 1. All right, now let's look at number 2. Again, we are still using substitution because they said x equals something. Makes this really easy. So we're going to sub this 3y in for x. So we get 2 times 3y minus 3y equals 6. So 2x minus 3y equals 6. Simplify. 2 times 3 is 6y minus 3y equals 6. Combine like terms. 6 minus 3 is 3. And then to get y by itself, we do the inverse operation. So we're going to divide by 3 on both sides. And y equals 2. Are we done? Of course, Jordan, we are not done yet, but we're almost there. We are going to sub 2 in for y into this equation. X equals 3 times 2, so x equals 6. And that means that our coordinate is 6, 2. All right, Sacred, what if I don't have it as y equals or x equals? I am shown this craziness. No worries. It's called elimination. So we are going to eliminate a variable. The way we do this, I'm going to use this example first, number 8. The way we do this is we multiply an entire equation by a number so that either the x's or the y's cancel out. You can start with the x's, you can start with the y's. It does not matter, just as long as you multiply the entire equation by the same value. And in number 8, there's nothing to do. Here's why. If I were to add straight down these equations, what happens to the negative 3x and the positive 3x? Negative 3x and positive 3x become 0. So then you can continue adding. 4y plus y is 5y. And negative 8 and negative 17 is negative 25. So you see how we eliminated the x, leaving us only one variable, which makes this really easy. All you have to do is solve for y. So to get y by itself, we divide by 5 on both sides. And y equals negative 5. Is that it, Louise? No, but we're close. Now we've got to substitute this value in for y into one of the equations. We'll do this one. It looks easier. And we're going to simplify and get x. So 3x plus, except y is negative 5, equals negative 17. So when we do that, we add 5 to both sides, and 3x equals negative 12. Divide by 3 on both sides, and x is negative 4. So our solution is negative 4, negative 5. But what if I want to check my work and make sure I'm correct? No worries, D'Angelo. I can show you how to do that. We're going to take the other equation that we haven't used yet, this negative 3x plus 4y equals negative 8, and we're going to sub x and y into these. So we have negative 3, x we said is negative 4, plus 4, y is negative 5. We get negative times a negative makes it a positive. This is a negative 20. And we get negative 8 equals negative 8. Is this right? By golly, it is, Michael. It is. So now we go on to number 7. Okay, this one I don't see a clear elimination. So what can I multiply the values by to get an elimination? So we're going to multiply, let's get rid of our x's. Doesn't matter, you can pick whichever one. You can do y's, you can do x's. I know that if both of them are 6, I can make 2 and 3 into 6 by multiplication, and they can eliminate. I'm going to make one of them negative so that they cancel out just like they did over here. So we're going to multiply this top one by negative 3, and this bottom one by positive 2. Negative 3 times 2 is negative 6x. Negative and a negative makes us a positive 9y. Negative 3 times 9 is negative 27. Do the same thing here. 2 times 3 is 6x. 2 times 4y is 8y. 2 times 5 is 10. So I can see now when I add vertically, what's going to happen to these x's? They're going to go away. So now we're left with 17y equals negative 17. Solve for y. I do that by dividing by 17 on both sides. And y equals negative 1. Are we done? No, Christopher, we are not done yet, but we are close. We are now going to sub this value in for y. And so now we have 2x minus 3, y is negative 1 equals 9. Simplify. And now solve. Subtract 3 on both sides. 2x equals 6. Divide by 2. And we get x equals 3. So our coordinate for this one is 3, negative 1. So that's solving systems of equations 3 different ways. Now go do the Go formative and practice and get ready for your test.